Going to have going around to show you the machines we have here. Mainly the three main processes, which are the drilling, we have the turning, and we have the milling. So the drilling machine, the milling machine, and we have the turning in the back there. The concept of the work is going to be about to classify them according to the axes we are going to have. So for the drilling machine, we have the drilling tip. It's a cutting tool, have two edges of cut. We had the flute to take off the chip while the drilling operation. The process of the drill machine is the rotation of the cutting tool around the z-axis, and the movement is going to be along the z-axis. The part mainly going to be stationary on the vise, or whatever the machine, the setup we're going to use to hold the part. I'm not going to run this one for you because we did that last week. The main thing we're going to have is going to be generating of the hole, which is have the same diameter of the cutting tool. The depth of the cut is going to be decided by you as the machinist, and we can have it either like the blind hole, you cannot see the light through, or the through hole, which is going to pass the depth to the other side. The other machine we're going to talk about is going to be the milling machine. Unlike the drilling and the tapping, the milling machine has three axes of rotation. What can I put the cutting tool here? Anyway, I missed the cutting tool. So the cutting tool here is going to have multiple teeth. Minimum is going to be 4. This one can go up to 5. The turning operation is discontinuous cutting operation. That's mean, unlike the drilling, where the cutting tool is going to be continuously in contact with the part, the cutting tool teeth is going to do the cutting, leave the part, and come back later. The concept is very easy. We have 3 axes of motion and 1 axis of rotation. The cutting tool is rotating around the z-axis. The table is going to move and moving along the z-axis. The other motion is going to be along the x-axis. The longest side of the table is the x-axis. The shortest side is going to be the y-axis. By having the movement of the 3 axes, we can do the cutting operation. If the cut is going to be by the face of the cutting tool, we call the face cutting. It's going to be done by the side of the cutting tool, not this one of course. The other cutting tool is look like the drilling bit. It's going to cut from the side, we're going to call it a peripheral cutting. A simple example on how to work on the milling machine. The cutting tool is rotating along the z-axis. We take it down to a certain value of depth. Okay, then when I start to feed, the cutting tool begins to work fine. Start to cut the layer, bring in a new face. So we just simply got a new face for the part. The quality of the face here will depend on the speed I send the part in, the feed rate. Faster is going to be worse, slower is going to be better. But at the same time, the slower, the RPM should be higher. Now, the 2 different types of the cut. The first one, which was fast feeding, with low RPM value, we call the rough cutting, which is higher depth of the cut. I just want to remove the material at higher rate. And I think that's one of the questions you calculated, the RMR, which is rate of material removal in the cubic millimeter per second. That's very important factor because faster removal of the material means that we're going to have a less time for the machining. I don't want to spend 3 hours cutting one part because this will be counting time for the machining that you need to pay money for it. So as I told you, I don't know what's the preferred cut. Otherwise, I will show you how to cut on the side. Now we go to the other machine, which is the turning, the basic one. Now, when you have a part,
You're like
which is
funny.
or symmetrical, then you need to cut it on the turning machine. Now, from the name of the turning machine, that means the part is going to turn. To do that, we're going to fix it on the chuck. The chuck is connected to a gearbox. The gearbox is connected to a motor. Back in the old days, the gearbox is actually connected to a pulley. The pulley is connected to a shaft, and the shaft is connected to the steam engine in the back. Thanks to electricity, we have a single motor for every machine. That's making work actually much easier. This is a distal one, a small one. We have larger one. We have the CNC one, which control the movement along the Z-axis and the X-axis by using a numerical control system. We have motors here, which are going to make the movement happen. How the machine working? We hold the part, we turn the thing. Doesn't work. Why? Done. Okay, that's for your safety. So it's not contact, it is rotating. One thing before we're going to start the rotating, usually you put the part in and you turn by hand and check if actually going to be linear or have some fluctuation. Because the fluctuation is going to be very dangerous during the operation. Now, if you just come here and show the cutting tool, this golden thing there, get it closer, show them the cutting tool. Okay, now this cutting tool is going to be fed in the work part. Can you come from that way so you can show the things there? Sorry for that. Yeah, no, just try to show the cutting operation. Okay, so the part is rotating along the Z-axis. This movement of the tool is going to be along the Z-axis, and this movement is going to set the depth of the cut along the X-axis. So I'm only going to touch the part and check how much speed I'm going to add. If you do that slowly, actually we have a reading here tell you what the depth of the cut is. So I just barely touch it. Okay, now I know that I have a contact with it. I go back, set the depth of the cut I would like to have, and start to feed the cutting tool inside the work part to sheathe it. It's not holding. I know what the problem. Maybe this one is not fixed. It's not fixed in. Whoever do that? Anyway. So I get to do that temporarily, but anyway, it should do the job. I don't know what the key is. And just to show you one of the cuts. That's what I want to do. I know the cutting tool is not fixed, so I'm going to just pause the video. Can you pause it?
I don't know how to pause it.
Yeah. Just press the same button, I think.